and the so-called legacy database problems are not there. However, I've noticed I have SQL-only solutions too. So, I mean, I'm not dogmatic about it. I mean, please make up your own mind on this, because it's just a way the community defines itself with. And some people say it's not only SQL. Some people say it's noSql, but it's whatever. That's where it started. To some extent, it's the historical reason. Graph only, right? There are a bunch of solutions which do graph databases too. And where it sits in the noSql community is it's still as part of the noSql community, but I just got them out separate because graph databases are graph databases. They don't define themselves as not SQL. You know what I mean? So I don't think I gave a great answer there, but I don't know if there is a good answer there.
So considering users just logging in and downloading tons and tons of things over the years, will get so much of records that SQL will not be able to handle it so easily as noSQL. SQL will not perform so better. So would you recommend moving to a noSQL database, and if in case moving, which one would be the best?
I mean, you know what the answer to the last one is. But I'm not going to compromise myself by answering that question. But the first part, right? I mean, in terms of like moving to a noSQL database, I am not sure that you should do it lightly. If the thing about databases is they are sticky. So you want to actually first thing you want to do is you want to benchmark to see that if that's exactly going to work for you. And if it takes more than a day to benchmark, or maybe like if you're patient 2 days, you should shelve that database. I don't think it's worth it. If it takes half a day to do it, then you should seriously consider it and see that you can run the performance test on it. Because all of these things are available and they should just work for you. Now, I'm not sure that just having a lot of records per user is a good enough reason to use a noSQL database. If you don't have a lot of changes to that user record happening all the time, I think any database can actually handle it. If it's just a matter of storing more and more data, I think Oracle can handle it so well, and MySQL can handle it fine. IBM, any of the existing databases can handle it quite well. But if you have online access at a rate where your reads and writes are heavy, then you should start benchmarking other systems. And you should definitely benchmark Citrus Leaf. And if it is the best, you should use it. Otherwise, use whatever else you find to be the best for you. Not a problem.
This question, Srini, I have a question.
Yes, please.
There has been two orthogonal views on how to scale databases in the pre-noSQL era. One was under the assumption that memory was becoming cheap, and you could infinitely have clusters of memory, and you could store data. A technology called Java Spaces came in. So you could completely replace disk writes and replace redundant memory writes for durability. That was one concept. Versus having commodity hardware and assuming that the commodity hardware can just get destroyed. So durability was made sure that it is replicated across in multiple clusters. Which one in your view, and why did the other one did not? Or both of you said that both of the technologies are seen in a single lens called noSQL.
In fact, both of the things that so the question here, Mani, let me repeat it. The question is about how do you scale? You can scale by actually putting all the data in memory and replicating it across a lot of installation, a lot of nodes, each of them in memory. And the other way is to use commodity hardware and then store it in those, which means, I'm assuming you mean flash. So where you can just store it in persistent memory and then have fewer nodes. Now the question was, which of the two is prevalent and why is one dying or not? I think both are valid. In fact, Citrus Leaf supports both today. And our customer uses in one deployment the memory as for an index lookup. They actually use memory backed by rotational disk because the storage is really cheap. For the actual user data, like the thing I showed in the real-time matching problem, they actually store it in Flash because the memory is too expensive. You would have to have a cluster of size 20 as opposed to a cluster of size 4 or 6 if you had to put it in Flash. I mean, you get enough performance for reads and writes. And then there are other techniques which are like age-old database techniques of writing logs, writing to disk as a log. I mean, this is stuff which is 25 years old. You know, as Suresh pointed out, none of this stuff is actually new. This has existed forever. It's just come down to the level of where it's available for anybody to use, and it's now also affordable. So pretty much you can build new kinds of applications which you could only think of for special cases like stock trading and so on. Now anybody can build a marketplace with millisecond response time, as the advertising people are doing. Did I answer your question? Okay, so both are valid. So a little bit about the technology. Well, we claim we are the world's fastest database in commodity hardware. And I think that is true because so far we've been able to. We haven't benchmarked it truthfully, but what we have benchmarked is benchmark our stuff. We looked at published benchmarks of others on the same kind of hardware. But more importantly, right, what have we done? What we have is essentially all the goodies that you've heard of in the noSql community, as well as the goodies you've heard of in the database community. So, which means ACID is important to us. Okay, and also the idea of driving, riding the technology curve of commodity hardware. SSDs, that's important. Also, the fact that it is clustered. Clustering is table stakes, as Mike Stonebraker would say. I mean, you don't build a database anymore which doesn't have clustering, automatic self-management. It makes no sense because when you have terabytes of data, it makes no sense that somebody has to have a DBA to go configure this thing to add another terabyte. I mean, you just drop more nodes in, and the database better absorb the data, and you're done. I mean, it should be as simple as that. And that is not easy to do, but once it's done, it stays done, right? I mean, that's the beauty of these things. So, because then you don't have to redo this stuff. And then we also have to do other things like analytics. Now, I don't know how much you want me to go into the technical details. I would have to go to the whiteboard for that. I'm happy to do that as part of questions. So we do a lot of hard stuff. And that's kind of one way to do that.
I have two questions.
Yes.
Ingress actually came up with a recent product.
Yes. For analytics, right?
Yeah.
Yes.
How do you compare? Is this somewhat related to that?
No, analytics is not really related to what we do.
Okay.
We are in transaction processing right now. Even though we do what I call, loosely real-time analytics, all that means is it is a fast way to do scans and queries on top of your mission-critical data. Definitely we're not planning to do joins. We're not planning to do anything which will slow things down. But we do allow querying of the mission-critical data extremely fast. That's what I mean by analytics. It's not the analytics which Hadoop does. So we sit on the side of Hadoop. We cover the area which Hadoop doesn't cover. I mean, it attempts to cover using HBase, but I think they have a long way to go.
Because they at least claim it's 10 to 20 times faster than Oracle, for example.
They are.
Yeah.
We are another order of magnitude faster than that. That's kind of how these things work. I mean, being faster than Oracle today is not that hard. Because Oracle is actually handling a general purpose database application. You cannot expect it to be fast also at the same time. You can definitely tune it for your specific application, but for giving you the right hardware and the software, I think it'll do fine for most applications in the world today. But the upper